Venture with me into a world so extraordinary, it seems drawn from science fiction. Picture a place where winds howl at 2,000 kilometers per hour, fierce enough to tear apart anything in their path. A mysterious blue giant where something incredible happens in its atmosphere. Actual diamonds fall like rain through its skies, and if that's not mind-bending enough, imagine a place where a single year lasts more than 164 Earth years. This isn't fantasy, this is Neptune, the majestic blue sentinel that holds some of the greatest mysteries in our solar system. Today, we're embarking on an incredible journey to the very edge of our cosmic neighborhood. We'll dive deep into the secrets of the last planet in our solar system, a world so cold and distant that it has only been visited once by human technology. Neptune, named after the ancient Roman god of the seas, continues to captivate scientists with its swirling storms, ethereal blue clouds, and phenomena that challenge our understanding of planetary physics. But before we set sail across the cosmic ocean to Neptune, make sure you're ready for this adventure. Hit that like button and subscribe to Exploring the Universe, your gateway to the wonders of astronomy. Trust me, you won't want to miss what's coming next as we unravel the secrets of this fascinating ice giant. You see, Neptune isn't just another planet, it's a world of extremes. When you look at those serene blue clouds from Earth's telescopes, you're actually witnessing some of the most violent weather in our entire solar system. Those peaceful-looking white streaks, they're actually clouds of frozen methane racing through the atmosphere at speeds that would make our strongest hurricanes look like gentle breezes. And somewhere in its depths, the intense pressure is so great that it transforms carbon atoms into diamonds, creating a glittering rainfall that never reaches the surface. This is just the beginning of our story about the mysterious blue world that guards the outer reaches of our solar system. A world that, despite being billions of kilometers away, has so much to teach us about the universe we live in. The discovery of Neptune stands as one of the most remarkable stories in the history of astronomy, a tale that proves the power of human intellect and mathematical genius. Unlike every other planet known until then, Neptune wasn't discovered by someone pointing a telescope at the sky. Instead, it was found first on paper, through the power of mathematics and human ingenuity. In the early 1840s, astronomers were puzzled by something strange happening with Uranus. The planet wasn't exactly where it was supposed to be, according to their calculations. It was as if some invisible hand was pulling on it, causing it to deviate from its expected path. This mystery captured the imagination of a brilliant French mathematician named Urbain Le Verrier. Le Verrier took on this cosmic puzzle with remarkable determination. For months, he worked tirelessly, filling page after page with complex mathematical calculations. He believed that another planet, yet undiscovered, must be causing these mysterious gravitational effects on Uranus. Through pure mathematical reasoning, he calculated not only the mass of this hidden world, but also precisely where it should be in the night sky. When Le Verrier completed his calculations in 1846, he sent a letter to Johann Gottfried Galle, an astronomer at the Berlin Observatory. The letter arrived on September 23rd, and that very same night, Galle pointed his telescope to the exact spot Le Verrier had predicted, and there it was, Neptune, floating in the darkness, exactly where mathematics said it would be, less than 1 degree from the calculated position. Think about how revolutionary this was. For the first time in human history, we discovered a planet not by accident or by scanning the skies, but by using the power of mathematics to predict its existence. It was like finding a ship in the vast ocean just by studying the waves it makes. This discovery shook the foundations of astronomy and transformed how we explore the cosmos. The story gets even more fascinating when you consider that another mathematician, John Couch Adams in England, had made similar calculations. However, due to a series of unfortunate delays and communication failures, his predictions weren't acted upon in time. This led to years of debate about who deserved credit for Neptune's discovery, adding a very human element to this scientific breakthrough. Neptune's discovery marked a turning point in our understanding of the universe. It showed us that the cosmos operates according to precise mathematical laws, laws that we can understand and use to uncover its secrets. This realization revolutionized astronomy, transforming it from a science of pure observation to one where we could predict and discover new worlds through the power of mathematics and physics. This mathematical discovery of Neptune remains one of astronomy's greatest achievements, showing us that sometimes the most significant discoveries don't come from what we can see, but from what we can calculate and deduce through the power of human reason. Let's dive into the extraordinary physical characteristics of Neptune, a world so incredible it challenges our imagination. If you could slice Neptune in half like a cosmic onion, you'd find a fascinating structure that tells the story of this giant world's formation. At its heart, Neptune has a rocky core about the size of Earth, but that's where any similarity to our home planet ends. Surrounding this core is something truly extraordinary, a vast mantle made primarily of water, ammonia, and methane ices. But don't think of this ice as being like what you'd find in your freezer. These are exotic forms of ice that exist under tremendous pressures and temperatures we can barely comprehend. The atmosphere of Neptune is a swirling masterpiece of cosmic chemistry. It's primarily composed of hydrogen, helium, and methane, but it's the methane that gives Neptune its most striking feature, that gorgeous blue color. When sunlight travels through Neptune's atmosphere, the methane gas absorbs red light, but reflects blue light back into space, creating that stunning azure hue that makes Neptune one of the most beautiful planets in our solar system. Speaking of size, Neptune is truly a giant among worlds. Picture this. If Earth were the size of a baseball, Neptune would be about the size of a basketball, approximately 17 times more massive than our planet. Its immense size makes it the fourth largest planet in our solar system, but despite its bulk, it's classified as an ice giant rather than a gas giant like Jupiter or Saturn. Now, let's talk about temperature and brace yourself, because Neptune is unimaginably cold. The average temperature on this distant world is negative 214 degrees Celsius. That's so cold that most gases we know would freeze solid. Yet paradoxically, Neptune has some of the most violent weather in our solar system, with winds that would make Earth's strongest hurricanes look like gentle breezes. Here's something fascinating. Despite being so far from the sun and receiving only a tiny fraction of the sunlight that Earth gets, Neptune somehow generates enough internal heat to drive these powerful atmospheric processes. In fact, it radiates about 2.5 times more energy than it receives from the sun. Scientists are still debating about the exact source of this excess energy, but it might be leftover heat from the planet's formation, combined with unique atmospheric dynamics. The extreme conditions on Neptune create some truly bizarre phenomena. For instance, scientists believe that deep within its atmosphere, the intense pressure and temperature conditions might cause carbon atoms to compress into diamonds, which then rain down through the planet's interior. Imagine that, a world where it literally rains diamonds. These extraordinary characteristics make Neptune not just another planet, but a cosmic laboratory where we can study physics under conditions impossible to recreate on Earth. Every new detail we learn about this distant ice giant helps us better understand not only our solar system, but also the thousands of Neptune-like planets we're discovering around other stars throughout our galaxy. Now, let me tell you about some of the most incredible phenomena happening on Neptune. Things that sound like they're straight out of science fiction, but are absolutely real. Hold on to your seats, because what happens on this distant world will blow your mind. Let's start with Neptune's storms, which are nothing short of spectacular. While Earth's fastest recorded hurricane winds reach about 400 kilometers per hour, Neptune's storms whip through its atmosphere at an astounding 2,000 kilometers per hour. These are literally the fastest winds ever recorded in our solar system. Imagine being caught in a wind that could circle the Earth in less than 20 hours. That's the kind of raw power we're talking about. One of Neptune's most fascinating features is the Great Dark Spot, which might remind you of Jupiter's Great Red Spot, but with its own mysterious twist. When Voyager 2 first photographed this enormous storm in 1989, it was big enough to contain our entire Earth. But here's the truly bizarre part. When the Hubble Space Telescope looked for it again a few years later, it had completely vanished. Since then, other dark spots have appeared and disappeared, and scientists are still trying to understand what causes these enormous storm systems to come and go so dramatically. But perhaps the most extraordinary phenomenon happens deep within Neptune's atmosphere, where conditions create something that sounds utterly magical: diamond rain. About 7,000 kilometers below Neptune's cloud tops, conditions are perfect for something remarkable. The intense pressure and temperature compress carbon atoms in the atmosphere, literally forming diamonds that then fall like rain through the planet's interior. These aren't tiny diamonds either. Scientists believe they could be millions of carats in size. Neptune's magnetic field is another fascinating puzzle. Unlike Earth's magnetic field, which is fairly well aligned with its rotation axis, Neptune's magnetic field is tilted by 47 degrees and offset from the planet's center by more than half of Neptune's radius. This creates an incredibly complex magnetic environment that scientists are still working to understand. It's as if someone took a giant magnet and stuck it into the planet at a strange angle, creating magnetic patterns unlike anything we see on other planets. These unique phenomena make Neptune one of the most fascinating planets to study. Each discovery seems to raise new questions about how such extreme conditions can exist and what they can teach us about the physics of our universe. If you're as amazed by these incredible facts about Neptune as I am, make sure to hit that like button and share your thoughts in the comments below. What surprises you most about this mysterious blue giant? Is it the supersonic winds, the vanishing dark spots, the diamond rain, or perhaps its bizarre magnetic field? Don't forget to subscribe to Exploring the Universe to join us on more cosmic adventures as we explore the wonders of our solar system and beyond. Let's explore Neptune's fascinating family of moons, a collection of 14 known natural satellites, each with its own unique story. But among all these moons, there's one that stands out as the true rebel of the solar system, Triton. Triton is not just another moon, it's a world of mysteries and contradictions. First discovered in 1846 by William Lassell, just 17 days after Neptune itself was found, Triton immediately proved to be different from any other large moon we knew. While most moons in our solar system orbit their planets in the same direction the planet rotates, Triton boldly goes against the flow. It orbits Neptune backward, or as astronomers say, in a retrograde orbit. This peculiar behavior was our first clue that Triton might not be a native moon of Neptune at all. But Triton's rebellious nature doesn't stop there. Despite being in one of the coldest regions of our solar system, this moon is surprisingly active. When Voyager 2 flew past in 1989, it captured something absolutely extraordinary: massive geysers erupting from Triton's surface. These aren't water geysers like the ones we have on Earth. They're massive plumes of nitrogen ice and gas shooting up to 8 kilometers high into Triton's thin atmosphere. Imagine standing on Triton's surface, watching these spectacular eruptions against the backdrop of Neptune's blue disk in the sky. The story of how Triton came to be Neptune's largest moon reads like a cosmic thriller. Scientists believe that Triton was once a free-floating object in the Kuiper Belt, similar to Pluto, minding its own business in the outer solar system. But at some point in the distant past, it wandered too close to Neptune's powerful gravitational field. Instead of being flung into space or crashing into the planet, Triton was captured into orbit around Neptune in what must have been a spectacular gravitational dance. This capture theory explains many of Triton's unique features: its backward orbit, its composition similar to Pluto's, and even its active surface all make sense if it was originally a dwarf planet that Neptune pulled into its orbit. But this cosmic kidnapping came at a price. Triton's orbit is slowly decaying. In the very distant future, about 3.5 billion years from now, Triton will spiral so close to Neptune that it will either break apart due to gravitational forces or crash into the planet's atmosphere. The rest of Neptune's moons are smaller and less dramatic, but each has its own charm. We have Naiad, the innermost moon, dancing close to Neptune's clouds, Thalassa, named after a primordial sea goddess, and Neso, the outermost moon, taking an incredible 27 years to complete a single orbit around Neptune. These moons, particularly Triton, tell us an important story about how our solar system formed and evolved. They remind us that the seemingly stable arrangement of planets and moons we see today is the result of billions of years of cosmic chaos, captures, and collisions. Each moon is like a chapter in an epic story of our solar system's history, with Triton being perhaps the most dramatic chapter of all, a captured world that continues to surprise us with its active geology and mysterious past. Our exploration of Neptune has been quite limited compared to other planets in our solar system. In fact, only one spacecraft has ever visited this distant blue giant, Voyager 2, which made its historic flyby in 1989. This remarkable encounter gave us our first close-up views of Neptune and revealed countless surprises about this mysterious world. During its brief visit, Voyager 2 captured stunning images of Neptune's dynamic atmosphere, discovering the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. The spacecraft also documented Neptune's surprisingly active weather patterns, with winds reaching speeds of up to 1,200 miles per hour, the fastest recorded in the solar system. The Hubble Space Telescope has been our primary window to Neptune since then. Its advanced instruments have allowed us to track seasonal changes in Neptune's atmosphere, monitor its strange dark spots as they appear and disappear, and study its collection of moons. Thanks to Hubble, we've witnessed remarkable events, like the birth and death of massive storms, and even discovered several new moons orbiting the planet. Looking to the future, several space agencies are considering missions to this distant world. However, reaching Neptune presents enormous technological challenges. The journey to Neptune takes many years. Voyager 2 needed 12 years to reach the planet. The extreme distance also means that solar power becomes impractical, requiring alternative power sources like nuclear generators. The intense cold near Neptune, reaching -214 degrees Celsius, poses significant challenges for spacecraft equipment. Additionally, the great distance from Earth means that radio signals take about 4 hours to reach Neptune, making real-time communication impossible. Despite these challenges, scientists are developing new technologies that could make future Neptune missions possible. Advanced propulsion systems, more efficient power sources, and improved communication technologies are all being researched. Some proposed missions include orbital satellites to study Neptune's magnetic field and atmosphere in detail, and even potential probes to explore its largest moon, Triton. The mysteries of this blue giant continue to captivate scientists and space enthusiasts alike. While we've learned much since its discovery, Neptune still holds countless secrets waiting to be unveiled by future generations of explorers and their increasingly sophisticated machines. Let me share with you some of the most fascinating features of Neptune that make it truly unique in our cosmic neighborhood. First, let's talk about Neptune's rings. Yes, you heard that right. While not as spectacular as Saturn's, Neptune's rings are incredibly delicate and have their own charm. They weren't discovered until 1984, and here's the interesting part. We found them during what scientists thought would be a routine observation of a star being blocked by Neptune. Instead of a simple disappearance and reappearance of the star, they noticed several quick flickers before and after. These flickers revealed the presence of Neptune's thin, dark rings. Now, let's discuss one of Neptune's most peculiar features, its moon Triton and its bizarre backward orbit. Imagine driving the wrong way on a one-way street. That's basically what Triton is doing. While most moons in our solar system orbit their planets in the same direction the planet rotates, Triton rebelliously moves in the opposite direction. This retrograde orbit is so unusual that scientists believe Triton wasn't born alongside Neptune, but was actually captured by the planet's gravity long ago, possibly after a cosmic dance that pulled it from the Kuiper Belt. Speaking of unusual features, let's talk about seasons on Neptune. If you think winter on Earth feels long, Neptune's seasons will blow your mind. Each season on Neptune lasts about 40 Earth years. This means if you were born during Neptune's summer, you wouldn't experience autumn until you were middle-aged. This extremely long seasonal cycle is due to Neptune's tilted axis and its lengthy orbit around the Sun, which takes about 165 Earth years to complete. Finally, let's explore Neptune's role as the solar system's cosmic bouncer. As the last major planet, Neptune's powerful gravity has a fascinating influence on the Kuiper Belt, a region of icy bodies beyond Neptune's orbit. Through a process called orbital resonance, Neptune's gravity creates areas in the Kuiper Belt where objects can and cannot exist. It's like Neptune is conducting a cosmic orchestra, keeping some objects in specific orbital patterns while clearing out other areas completely. This gravitational influence is so significant that it helped astronomers predict the existence of many Kuiper Belt objects before they were actually discovered. These remarkable characteristics make Neptune not just another planet in our solar system, but a world of endless fascination, continuing to surprise us with its unique features and mysteries. Its delicate rings, rebellious moon, marathon seasons, and gravitational influence on our solar system's outer regions all contribute to making Neptune one of the most intriguing planets in our cosmic neighborhood. Leading scientists from around the world continue to be fascinated by Neptune's mysteries. As Dr. Amy Simon from NASA's Goddard Space Flight Center puts it, Neptune is a constantly changing world that challenges our understanding of planetary atmospheres. Its extreme weather patterns and dynamic storm systems make Earth's weather look tame in comparison. The debate about Neptune's formation has intensified in recent years. Dr. Ravit Helid from the University of Zurich presents an intriguing theory. Our models suggest that Neptune might have formed much closer to the Sun than where it is today, perhaps even closer than Uranus. The planet then migrated outward over millions of years due to gravitational interactions with other giant planets and smaller planetesimals. This theory of planetary migration has gained significant support within the scientific community. Professor David Nesvorny from the Southwest Research Institute explains, "The more we study Neptune, the more we realize that the early solar system was far more chaotic and dynamic than we previously thought. Planets didn't simply form and stay in place, they moved, interacted, and reshaped our entire solar system." Perhaps one of the most debated topics among planetary scientists is the origin of Neptune's largest moon, Triton. Dr. Catherine Delaney from the European Space Agency presents a compelling narrative. Triton's retrograde orbit tells us it simply couldn't have formed alongside Neptune. The evidence strongly suggests it was once a dwarf planet from the Kuiper Belt, similar to Pluto, that was captured by Neptune's gravity in a cosmic game of catch. Building on this theory, Dr. James Morrison from the Australian National University adds, "The capture of Triton was likely a violent event that completely reshaped Neptune's moon system. Any original moons Neptune might have had were probably thrown out of orbit or crashed into each other, explaining why Neptune's current smaller moons appear to be debris reassembled after this cosmic catastrophe. Some scientists even suggest that understanding Neptune and Triton could help us understand other solar systems. As Dr. Sarah Matthews from MIT explains, the Neptune-Triton system provides crucial clues about how planetary systems evolve and interact. Similar captures might be common in other solar systems, helping explain some of the unusual exoplanet configurations we've observed. Recent computer simulations have provided new insights into Neptune's composition and internal structure. Dr. Michael Wong from the University of California, Berkeley notes, "Our latest models suggest that Neptune's interior might be more complex than previously thought, with layers of different compositions and possibly even a liquid diamond ocean at certain depths." These ongoing scientific discussions and debates remind us that even with our advanced technology and understanding, Neptune continues to surprise us. Each new study and observation brings fresh questions and challenges our existing theories, making it one of the most enigmatic and fascinating planets in our solar system. Neptune serves as a crucial piece in the puzzle of understanding how our solar system formed and evolved. Think of it as a cosmic time capsule, preserving conditions and characteristics from the early days of our solar system that have long since disappeared elsewhere. Its position, composition, and unique features provide invaluable clues about the processes that shaped not just our cosmic neighborhood, but potentially countless others throughout the universe. When we study Neptune, we're not just learning about one planet. We're uncovering universal principles about planetary formation. The way Neptune's powerful gravity interacts with the Kuiper belt, for instance, helps us understand how planets can shape their surrounding space and influence the distribution of smaller bodies in their orbital regions. This knowledge has proven invaluable when studying distant solar systems, where we've discovered similar patterns of orbital resonance and gravitational influence. Neptune's composition and structure have also revolutionized our understanding of ice giants, a class of planets we're increasingly finding in other solar systems. By studying Neptune's atmosphere, internal structure, and magnetic field, we've developed better models for identifying and understanding similar planets orbiting other stars. In fact, current observations suggest that Neptune-sized planets might be among the most common type of planets in our galaxy, making our blue giant an essential reference point for understanding these distant worlds. The planet's unique characteristics continue to challenge our theories and expectations. For example, Neptune's powerful storms and atmospheric dynamics, despite its distance from the Sun and low energy input, force us to reconsider our assumptions about what drives planetary weather systems. These insights are particularly valuable as we study atmospheres on exoplanets and try to understand what makes a planet potentially habitable. Looking to the future, Neptune holds immense potential for new discoveries. Its complex system of moons, particularly Triton, with its nitrogen geysers and possible subsurface ocean, represents one of the most promising locations in our solar system for studying potential extraterrestrial life conditions. The mysterious dark spots in Neptune's atmosphere, its poorly understood magnetic field, and the possibility of diamond rain in its middle layers all present exciting opportunities for future research. As our technology advances and new missions are planned, each aspect of Neptune we uncover helps us better understand our place in the cosmos. The planet serves as a reminder that even in our own solar system, there are still countless mysteries waiting to be solved. Every new discovery about Neptune not only enhances our understanding of planetary science, but also helps us piece together the greater story of how solar systems form, evolve, and potentially nurture life. The study of Neptune truly represents the cutting edge of planetary science, where each answer we find leads to even more fascinating questions. As we continue to explore this distant world, we're not just learning about a single planet. we're uncovering fundamental truths about our cosmic environment and our place within it. Neptune stands as a testament to the endless wonders that await us in space, promising countless discoveries for future generations of explorers and scientists. As we conclude our journey through the mysteries of Neptune, we can't help but be humbled by this majestic blue giant. From its mathematical discovery that revolutionized astronomy to its powerful storms that dwarf anything we see on Earth, Neptune continues to be one of the most enigmatic and fascinating planets in our cosmic backyard. This distant world, with its diamond rains, supersonic winds, and mysterious dark spots, reminds us that we've only scratched the surface of what our solar system has to offer. Every new observation, every piece of data we receive, seems to raise more questions than it answers. The more we learn about Neptune, the more we realize how much remains unknown. Think about it. A planet so far away that it takes light 4 hours to reach it, yet its influence shapes the very structure of our outer solar system. A world where each season lasts longer than a human lifetime, where storms could swallow Earth whole, and where a captured moon might hold clues to the early history of our solar system. These aren't science fiction concepts. This is the reality of Neptune, sitting right there at the edge of our planetary family. We've come a long way since that remarkable night in 1846, when Neptune was first spotted through a telescope, confirming what mathematics had already predicted. Yet, in many ways, we're still at the beginning of our understanding. Each new discovery about Neptune helps us better comprehend not just our own solar system, but countless others throughout the universe. If you've enjoyed this cosmic journey to the far reaches of our solar system, I invite you to join our community of space enthusiasts here at Exploring the Universe. Hit that subscribe button and turn on notifications to ensure you don't miss any of our future explorations of space's greatest mysteries. Drop a like on this video if Neptune's secrets have captivated your imagination, and share it with friends who share your curiosity about the cosmos. Remember, every time you look up at the night sky, somewhere out there, beyond what our eyes can see, Neptune continues its slow dance around the sun, keeping its secrets and waiting for humanity's next visit to uncover more of its mysteries. Your support helps us continue bringing these fascinating stories of our universe to life. Together, we can explore the furthest reaches of space, one video at a time. See you in our next cosmic adventure.